Hey, how are you? Hope you're doing well. And as I said last week, today primarily I'm handing out the summative assessment for Unit 9 that I'd like you to complete by Thursday. But before we get to that, I want to talk about what are some changes we have in distance learning and chemistry. You're going to see a new document called the Unit Study Guide where I've kind of lay out everything, at least through the end of this month and into May. There's going to be some changes based on the new pass, no pass approach that we're taking towards your learning. And then I'll spend some time reviewing that formative document that I gave you last week in preparation for the summative. I'm going to post the summative right after this. You'll see it right away. Please try and get that done by Thursday. And then tomorrow on Wednesday, you're going to see I'm going to post an assignment based on the study guide and basically start thinking, I'm going to post on Tuesday and it's due by Tuesday, ideally Monday night at midnight. But I got to know that you're checking in every week, and hopefully, I'll see you in office hours. And let's start by talking about this unit study guide. Let me look at that just briefly right here. Boom, 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 boom. And here it is right here. And one thing I want you to note is that obviously I'm going to label the weeks by numbers, trying to keep that idea going. And you can see that this is laid out from now until all the way until May 8th. Each week, the idea is we're going to have an essential question, and your job is to answer that essential question. There's a standard, you need to define energy and describe how it can be stored and transferred. And these are the tasks that you can do. In general, one thing you have to do every week right away, should take you 3 to 5 minutes at most, is this do now. And when you look at this do now, it's just simply a Google form that has a little quote, and it asks you to check in. It tells us what our essential question is, and then there's 3 short questions that you want to answer afterwards. So please do that right away. As soon as you get the assignment and you've looked at it on the computer for the first time, just check that out and get that done. You're also going to see 2 other things that we're going to do every week. And you're going to choose this or this, but you have to do the reflection in this one. And so I have a Google document that I can check for originality that will ask you what you know about the essential question, what do you want to know about the essential question, what you learned about the essential question. The reflection is about how did that process go. Everybody needs to at least do this document and write one of the reflections. If you don't feel like writing an answer to this essential question as your proof of passing, you have another option, and that's like these quizzes that we've been doing, these practice quizzes. And if you do that at a good enough level, you'll be considered passing. I'll be evaluating this, either this after you turn it in or the form. And if based on your answers and your questions, don't be surprised if maybe I reach out to you and ask a few more things just to prove that you understand and you passed. And you can use this standard. You can define energy and describe how it can be stored and transferred correctly. So there's a lot of vocabulary you got to pay attention to. You got to think about examples and all that stuff. And every week we're going to follow that format. A new essential question, solve a variety of Q equals MC delta T problems, the do now right away, and of course these 2 forms. Looking at these forms for the first unit, what you get for the Google Doc is just obviously a question. And when we scroll through it, I ask you to think about these questions. If you know anything about them, write it down. That's what you, whether you know something or not. Then I give you a bunch of resources. I'll put our screencast in here and then a bunch of links that you could check and think about. But you want to work for answering these questions. These are our vocabulary terms. These are the questions to answer. The more you practice with that, obviously, the better you'll do. Once you feel like you're good with all that and you've looked at this link and filled this in, you're probably ready to answer this question. How do chemists communicate about energy movement? And what you would do then is either one, um, following this concept of originality and this idea that all answers must contain the following: a complete answer to the question, key vocabulary terms, and an example of endothermic or exothermic in your life. You would write here, just write your answer. 3 to 7 sentences. Think a little bit like CER. But the big line is, do you understand? And I'll be able to look at that and see how well you're doing. If you don't want to write, you can always just do the forms quiz. On that Google Forms quiz, it's going to look like this. You're going to be prompted right, though. Before you do this quiz, you should have reviewed what do you know, and you know the questions and vocabulary. You should have finished the reflection also, and then go through and do the quiz. That'll get scored, and of course, if the score is passing, you get a P. If it's not passing, I'll reach out to you and ask for a few things. Keeping all that in mind, then, let's just look at the reflection form at the bottom. When reflections at the end, just make sure you have a good reflection, and you just have to respond to any one of these three prompts. Did you run into any problems? I'll describe connections, and what strategies did you use? Well, let's get back to then this idea. We've talked about these, but let's talk about this summative assessment that I'm giving you today, and you want to get done with, hopefully by Thursday if you can fit it in. First of all, you had this form that I gave you, and I want to go through the answers to this and talk about the answers to this. I hope that you worked with it and you can communicate with me how well you did. I can obviously look at it too, but let's just talk about your answers to this. So, first of all, the first question: a natural gas and storage tank has a volume of, look at that, 2,120,000 liters at 24.3 degrees. The next day at 24.3 degrees, the next day it falls at 13.3 degrees below zero centigrade. That's like, obviously, that's a big temperature change. That's a very large temperature change when you think about degrees Celsius. Will the volume of the gas naturally increase or decrease, and explain your answer? So you want to look at what you know a volume and a temperature. And what did the temperature do? The temperature went down. You should think about your relationships between temperature and pressure, and what would happen. And so the idea, of course, is, let's go up here and think about this. The idea is that it would want to decrease. It would want to go down because, well, as the temperature goes down, the kinetic energy of the particles goes down. So as they slow down, that means these particles aren't like driving all over the place and going away. They just they can stick or get closer together, and so the volume will contract. So you want to think about that as you go through that answer and question. Then there was a series of questions about increase, decrease, or stay the same. Let's just go through that quickly. For each statement, fill in the blank. If a gas is heated, the average speed of its particles increase. More kinetic energy, they can spin more, they can slide more, they can vibrate more, but no matter what, they have more kinetic energy. When you look at the pressure around a balloon going down, if the pressure goes around the balloon, think of that bell jar when I had the balloon inside the jar. If the pressure on the outside goes down, there's less collisions on the outside. And so the volume will increase because there's still the same number of collisions on the inside, and the flexible container will expand. That's Boyle's law. And if the gas is cooled at a constant temperature, the pressure will decrease. Cooler gases means the particles are moving with less energy, less collisions, less frequency. That's a decrease. As the gas is heated at a constant pressure, the volume will increase. And that's just as temperature goes up, you can understand that the particles will want to move farther apart. Constant pressure means it's probably inside of a flexible container, so that just means it'll expand, right? The balloon will inflate. If you took it from a cold in your freezer and put it outside, it would get bigger. As more gas particles are added to a container at a constant volume, the temperature and pressure will increase. Think of blowing up a balloon, right? Obviously, if you put more particles inside, there's going to be more collisions. Then we have this scenario question. And in this scenario question, you're going to be asked the question similar to this. We're talking about trying to inflate a potato chip bag, right? About 1.25 liters. You want it to be about standard pressure and standard temperature, a little high on the pressure, a little low on the temperature. And you have available a chemical reaction to produce this gas, carbon dioxide. And if that gas is produced, it'll inflate. So the question is, how much of this and how much of this do I need to get 1.25 liters of carbon dioxide at 24.5 degrees temperature and 1.10 atmospheres? That's the question. And so when we go through this, let's think about this. It says first, Solve for how many moles of CO2 you'll need. Well, if we're going to solve for moles of CO2, we're going to have to use the ideal gas law and rearrange it, right? The number of moles equals pressure times volume divided by RT. Identify your pressure, your volume, and your temperature. Hey, you guys, tank, right? Remember this. Don't forget this. You got to get those temperatures in Kelvin. And so add that 273 to get 297.5. Once you have those, you take the pressure times the volume divided by RT. This over this divided by RT. So if I'm my calculator, I go 1.25 times 1.01 atmospheres divided by 0.08206 liter atmosphere mole Kelvin times 2 divide by 297.5. I'll end up with this answer right here. That's my answer to question 1. So you're going to have a question like that on your summative. Obviously, variables will change, be a different reaction, but you want to be comfortable with that. Then it says solve for how many grams of baking soda. This is baking soda. Make sure you identify what you know exactly. You need to start with a bridge, moles of CO2, then grams of here. So if we know how many moles of this, the question is how many moles of that, and eventually we'll get to the mass. So to get for moles to grams, I just take the number of moles I have, and then I use the mole ratio. The mole ratio for every 1 mole of this, it's 1 mole of that. And because of that mole ratio, I put that right here, and then I just multiply by the molar mass of baking soda. 22.9 plus 1.01 plus 12 plus 3 times 16. And so if on my calculator I take 0.0157, my answer to number 3 times 84.01, I end up with that answer. So I need about 4.3 grams if I wanted to make 1.25 liters of CO2. I could also figure out how many grams of acetic acid I would need. For that, again, it's the same amount of carbon dioxide. The difference now is I'm ending with acetic acid. Its molar mass is lower, so I need less mass of it. The mole ratios are the same, 1 to 1, and so 0.0517 times 16.06 gives me this number right here. Now, time for the big kahuna. I know, I'm just being silly, but I have a swivel chair and I can play around. Answer the following questions. And so normally, in normal circumstances, we'd have had you written right out of CR. We'd have had you done a lab relevant to this. But what we want you to do is think about this. Suppose you are working and you're trying to fill those potato bag chips up with 1.25 liters, but now the weather's changed and so the pressure's gone down. Would this cause your bag to be overinflated or underinflated? Would it feel like really firm and like overinflated, or would it feel like not so full, underinflated? And you want to remember that you're going to use your 3.10 grams of acetic acid, your 4.34 grams of this. You're going to try and make exactly this much CO2. The only difference now is, well, the pressure went down. So if the temperature stays the same, but the pressure goes down, what should happen to the volume? Conceptually, you should understand Boyle's law and understand what should happen. Mathematically, prove it. How do you prove it? Well, what will the volume be of the airbag if it inflates when the pressure is at this? So the pressure is now lower. We calculated everything when the pressure was 1.10 atmosphere and we wanted to get our 1.25 liters. Now that the pressure goes down, what should happen to the volume? Well, when we plug and chug P1 V1 times P2 times V2, take this times this and divide by 0.985, we see that, yeah, it makes sense. The volume went up. That means it will overinflate. Pressure, volume, and temperature, all of those are questions that you need to answer in your own words. I want to emphasize that. I'm not going to talk much about those, but I do want to talk to you about this last question. Explain how using gas behavior, I'm sorry it said temperature, it should have said pressure. Decreasing leads to your letters and answer and B. And really what you want to do is talk about pressure and volume inversely related. This is Boyle's law. If the pressure decreases around the outside of a flexible bag, that means there's less collisions on the outside of the bag. Collisions on the inside of the bag remain the same. And that leads to the space expanding since there's relatively more collisions on the inside of the bag versus the outside of the bag. So you have a summative coming up. There it is. Look at this. Oh my God, some questions, a prompt about a car airbag with a chemical reaction. And there's that chemical reaction. Figure things out. When you write your answers, you can either type or insert a picture of your work. I want you to know that you have both choices for that. And please be clear with that when you do it. Make sure you do one or the other. Everybody needs to do this. When we're looking down at the CER portion, you're going to see again, well, the volume of the airbag. You can type or insert a picture here, show your work. And when you get to these definitions, what is volume? Cut and paste. Don't just cut and paste definitions. These answers are being screened for originality. I have a setting I can use. So please just use your own words. Do your best to explain in your own words. And of course, here's a question just like we saw before. So you want to make sure that you're feeling comfortable with all that. And I hope now you have a better idea. We talked about their study guide, this whole pass or no pass. I'll be in touch with you if it's the work you didn't pass. Relative. We talked about that assignment that you got for Friday and now our summative test. And please note that I'll post a new assignment tomorrow in addition to doing that test. We're going to double up a little bit this week. And then we're going to try and keep it simple from then. You guys, I hope this helps. Please stay healthy. Take care of yourselves. And I'll see you again tomorrow.